Welcome to qnawire.
Hi, so over here we want to complete the following reactions, and in order to do so, we need to identify the functional groups that are going to be responsible for the reaction. So, for example, in the first reaction, we're going to have a carboxylic acid plus an alcohol that is going to be in concentrated sulfuric acid. So, this is going to generate an esterification, which would be acid catalyzed. So, compound A would correspond to the ester of this carboxylic acid with the corresponding alcohol. So, this would be H3C, carbon double bond carbon, CH3, H, and over here we're going to have COO, CH2, CH3. Let me make more space here just for things to not get confused. O, CH2, CH3. This would be the corresponding compound. Now, for the next reaction, what we want to know is what compound, after the reduction, generates a primary alcohol. And the answer to that is going to be a carboxylic acid. So, a carboxylic acid is going to generate, on the presence of lithium aluminum hydride, a primary alcohol. So, for this reason, we know that compound B, I'm going to use this, this space instead, compound B should correspond to the associated carboxylic acid over here. Next up, for compound C, what we're going to have is going to be the carboxylation of a Grignard reagent. How do we identify the generation of a Grignard reagent? By the presence of magnesium and the ethyl ether under reaction conditions. So remember that the carboxylation of a Grignard is going to generate a carboxylic acid starting from an alkyl halide. So C needs to be, let me put it in purple instead, C is going to be an alkyl halide. In this case, compound C would correspond to our phenyl group, and here we are going to have different options. I'm going to use bromide, just in this case. You can also have chloride if you want, or essentially any halogen for the generation of the Grignard reagent. So chlorine or bromine are going to be preferable. Next up on D, we're going to have a carboxylic acid with SOCl2. This is going to generate an acid chloride. So D is going to be an acid chloride corresponding to CH33, C, COCl, which, if we expand the formula, will look like this. The corresponding acid chloride. Now let's go with compound E. What we're going to have is an SN2 substitution with the Cn minus ion in order to generate this compound. And after that, we're going to have the hydrolysis of the corresponding nitrile. So, in order to generate this nitrile, we're going to have to start with an alkyl halide. So in this case, compound E is going to be the alkyl halide corresponding to CH3, CH2, Br. And finally, compound F would correspond to the hydrolysis of the nitrile, which is going to generate a carboxylic acid. In this case, the carboxylic acid would be CH3, CH2, COOH, or expanding the formula, CH3, CH2, COOH. And finally, we're going to have an acid chloride plus something that is going to generate a carboxylic acid. And in this case, to generate the carboxylic acid starting from an acid chloride, the compound that we need to add is simply water. And with that, it would be all. Thank you very much and have a good one.